I knew that. Okay, so we're going to go ahead and get started. So let's talk about page 70. You should have page 70 open up on your computer. Do you have it opened up? If you don't, you need to have it opened up.
So you got to plug somewhere close by.
Right there. See it? That's the closest one I got. Okay, so if you look at page 70, you're going to see some questions that it's asking you for number 20 and 21. Now, we kind of went over this yesterday, but we didn't quite. So what we have is we have a graph. And this graph has person A and person B, and it's showing their position. So what it's asking you for is it's asking you the change in the position that you're in. So you're having the change in position of A and the change in position of B. So only thing you have to do here is for this, you start with where they were, 9 meters north, and then you do half times 6, and times 3, which will give you 9. So half of 6 is 3, right? 3 times 3 is 9. That's what they're doing there. This one is 8 meters north, so you're going to have half of 4, which is 2. 2 times 4 is 8. Simple question, simple answer on question number 20. Question number 21 says the motion of 2 people moving south along a straight path is described on this graph. So we have a graph, number 14. How is that one different than 13? How is that graph different? Someone? Yes, we're on 70. So I'm asking you, what's the difference between figure 13 and figure 14? What is the difference in these two graphs?
There's one horizontal.
Yep. So when we're looking at the velocity, we look at the 13, they're both starting at the same place, aren't they? At the same time. But if we look at 14, one is starting at 0 and one has a velocity of 2. So they're running at different speeds. That's what the difference is. So what it's asking us is that's asking us what is the change in C. To be able to do that, we have to look and see what the change is, which is rise over run. That's 8 meters per second. What is the change in D? Well, same thing, is 4 meters per second. That's the answers to those questions. The next thing that you see is page 71, which is continuing on. When you look at position with average acceleration, that is object final equals initial position plus initial final plus time final plus 1/2 of acceleration time final squared. You're going to have to be able to know what these variables are and what they stand for, okay? I'm writing them out for you now so you'll have them in your notes. So when you have the test, you know how to find the variables. I'm giving you the formula, but I'm not giving you the variables. You have to read the problem to find that out, okay? So if you have something that has a position with an average acceleration, this is the formula that you're going to use. If you have one that has a constant acceleration, you would use this velocity final squared equals velocity initial squared plus 2 times acceleration, and then your change in position. Remember, your change in position equals position F, which is your final, minus your position initial. So now, in your textbook, turn to page 72. So on page 72, they give you an example. example is showing you of a car. And if you look, you have a beginning and an end. You have a plus vector, and you have an arrow showing you which way you're going. You have your dot system. So if we want to look and see what the system looks like, we have begin, what is that telling us the car's doing?
Speeding up.
It's at a stop first, right?
Mm-hmm.
And then it's starting to speed up, which is changing the velocity of it, right? Got it so far? But then it has this on the bottom. What is that telling us?
Okay.
Telling us what the acceleration is. So what they're doing is they're taking from here to here, and they're giving me the average acceleration, okay? So that's what it's showing here. And then, of course, the person is really speeding up here, and here's the end. Here's our scenario, okay? So I'm going to read the question. We're going to figure out where we get these numbers from. We're going to figure out this formula here is one of the ones you wrote down, except it was changed. Now, you're not going to have to change the formula. I'm already going to have the formula changed for you, so you don't have to learn how to rearrange it and all. I'm just going to give you this right here, and what you got to do is you got to find these to get this, okay? But the main thing is I want to make sure you can do it on your calculator on your device. Everybody ready? So, the problem says, an automobile starts at rest at an acceleration of 3.5 meters per second squared. After a traffic light turns green, how far will he go when he travels 25 meters per second? So based on that, he's at a stop sign. He has no position. He hasn't changed it. He doesn't have any velocity. But when that light changes, 25 meters per second, and his acceleration is 3.5 meters per second squared. It's trying to find out what is his final position. Okay? So, open up your calculator. And what I want you to do is I want you to see if you can put this formula, and I'm going to highlight it with green. If you can put that formula in your calculator, and are you going to get that number? So go. It's what's so great about it is you just got to push the buttons. Yeah. Got it? Got it, Tank? Okay.
That's 25 or 2.5.
That is 25, ma'am, meters per second.
Oh, I ain't turning it on.
So it's 0 plus 25 squared minus 0.00.
How you do a fraction on here?
Okay, so can I show you how to do it? You ready? I'm going to help you with the calculator. First thing you want to do is alpha y enter. Alpha y enter. Is everybody there? Do you have your fraction now? Y, that's that stat button up at the top, and enter. Alpha y enter. And that gives you a fraction. Who doesn't have their fraction? I'll come help you. Right, good? Okay.
I don't have mine.
All right. Now that you have it, type in what's on the top. Can I borrow? Yep, that's it. So you're going to do 0 plus, I'm going to write on the board. So you're going to do 0.00 plus, you're going to open your bracket, you're going to do 25, you're going to close your bracket, and you're going to use the square key. Now the square key is the one where it says X square on the right, on the left-hand side, okay? Then you're going to do subtract 0.0. And once you have that done, so it's 0.00 plus 25 caret or squared minus 0.0. You're going to use this little button right here. And this is going to actually get you to the bottom.
Don't you gotta square that last 0.0?
Nope, because it's inside and it's not outside the bracket. Or maybe I do. Nope.
Because you got a square right there.
Velocity, okay, let's square it. I'll put my bracket there. Thank you, baby.
No, I'm just
Okay.
asking because you.
No, you're right. You're right. You're right. Don't act, I mean, you're right. All right, so then once you hit that little button to get you down here, then you're going to do 2 open bracket 3.5. You're going to use the x squared again and hit enter and see what you get.
25.51020480.
You said,
I think he 89.
You didn't get 89. I didn't either. And I did exactly what she said.
yes, you did. All right, we got it, Jay.
Jump is difficult.
So your jacket is good. You don't mind.
I got 25.551. Is that what you got?
Man, you can wait for me, man.
Is that the number that you got?
Let's work it.
See, we got the same number.
Yes, ma'am, we did.
What's wrong?
Sir,
My record screen too.
don't break the computer.
It's not working.
Why is it not
I
working?
don't know what you do. I don't know what those things are.
Okay, let's try something else. You ready? Since that wasn't the right answer, let's do this. We're learning today. Do your alpha y enter to get your fraction.
I've been good this off.
Yes, ma'am. 0 plus 25 minus 0.
0 plus 25 minus. On the top,
On the top.
0 plus 25 minus 0.
Right. And then on the bottom, do 2 times 3.5.
Squared.
Nope.
3.57142857.
Okay. Try another one. Ready? 0 plus.
0 plus. Hold on. I got to go to my alpha y. 0 plus
Okay. 2 open brackets.
2 opening.
2 open brackets.
Okay, got it.
25.
25.
Close bracket.
No.
Close bracket. Square it.
Squared.
Minus.
Minus.
Open bracket. 0.0. Close bracket. Square. Another close bracket. And down here at the bottom, do 2 times 3.5 and see what you get.
$89.28.
Now we got it right.
89.28571429.
Yes, ma'am. So what this was is this was an exercise on using the calculator. Now let's look at it. This tells us that we need to have position initial, which is 0. But we have to use this fraction here, don't we? Right? This is squared, that's squared, but that is not. But we have to have open brackets here to tell it to subtract first before we add. So on your ISM book, write that down. just like this. So what I want you to do is I want you to have this, but I want you to write this down because this is what your calculator has to do. So it's alpha y equal to get your fraction, right, guys? Is everybody good so far? It's passive. We're going to be practicing with this calculator for the rest of the year. So we all got the right answer? Now let's look at the first problem there. So in your ISM book, write down the variable you think you have there, please. Y'all are doing so good. I know this is very hard for you today. Y'all staying awake, doing the best you can. Is what it is. Yes, sir? That's question number 23. Question number 23, guys. And what I'm going to do is I'm going to give you the equation, and we're going to see if you can solve it.
In the calculator?
Yep.
I
Will you
got
put
a page.
pennies in the calculator?
Mm-hmm.
I see right.
Okay? So I'm telling you right now, question number 23 is time equals velocity final minus velocity initial over acceleration. So you have to read it to find your velocity final, your velocity initial, and your acceleration. And once you do that, plug that in and tell me what you get.
Can I get the 3.3 down?
Excuse me?
No.
Okay, cool. Number 23 says a skateboard is moving at a constant speed at 1.7 meters per second when she starts on an incline that causes her to slow down with a constant acceleration of a negative 20 meters per second. How much time passes from when she begins to slow down until she begins to move back down the incline? So, Tank, what is my velocity final? What is she doing? That's your initial.
23.
23. So Jay told me that the velocity initial is 1.75 meters per second. So my velocity final, Tank, is where she's going to stop. What will it be? If she stopped, what would be the number that if she stopped? 0, because she's not going nowhere. You got it? 0.00 meters per second. All right. Ladies, one of you. What is my acceleration? Miss Little, do you know?
Somebody look, let me get my book.
All right. Miss Pyatt, do you know?
My book not 20 pages.
Can I get it right there? Negative 0.
No.
Hold on, give me time. I get it.
I know you will. I know this is something that you might want to think about doing, and I thought about it yesterday. I thought about it this morning.
Negative 0.2.
Okay, 0.20 meters per second. Have you ever thought of opening your book and snipping the pages that you need for the week, and then you won't have to worry about getting on the internet and doing that while you're here? Thought about that. So, my acceleration is negative 20 meters per second squared. All right, Jeffrey. Tell me, how do I plug and chug this? Let's go. Yeah, you do. So T equals, Miss Sloan. What's my velocity final, Jeffrey?
0.
Thank you. Okay.
The track 1.75.
And I'm going to divide that by my,
Negative 20. 120.
okay, Jay, on your calculator, do that. So everybody else, are you ready? Alpha y equal on your calculator. So you can get your fraction. Keep going, Jeffrey. And you're going to put 0.0 minus 1.75. Remember, you're going to use that arrow to get down here. And you're going to put negative 0.20. And Jay is going to tell me the answer.
Stop dozing off.
What'd you get, Jay?
8.75.
8.75 meters per second. Okay? Sig fig rule? 2 digits?
8.8.
8.8 meters per second. Perfect. Do you have it?
I don't got one more right now.
Okay? So that's the answer for 23.
3.2 got like 40.
And now we're going to try to do number 24. Now we got this, and we got a calculator that works really decent now, so we're good. I'm going to give you the formula again. 24 is acceleration equals velocity final minus velocity initial over time. That's my formula. Miss Sloan's gave me that. First thing I'm going to do is I'm going to write down my variables. And then I'm going to go back and read the problem. Problem for 24 says, a race car travels on a straight racetrack with a forward velocity of 44 meters per second and slows at a constant rate to the velocity of 22 meters per second over 11 seconds. How far does it move during the time?
The velocity final is 44, right?
So the velocity final
It'd be 44.
is
11.
22. Here's our problem, right? I'm getting ready to tell you. So what makes the velocity initial?
44.
It's the wording. What's my time?
11.
Okay. So let's look at it again. A car travels on a straight track with a forward velocity of 44 meters per second. Racetrack, 44 meters per second. That's its initial velocity. And then it says, and slows at a constant rate with a velocity of 22 meters. That's why. Think about it. He's going fast, and then he slows down. This is the thing. If you're doing it at home and you're doing the math problem and you don't see the answer, guess what? You got it backwards. Look back again. Okay. So, who wants to do the math this time? You do, don't you, baby? Go ahead.
Is this right? Did I set this up right, Miss?
This said 3.2, right?
What, baby?
This said 3.2.
Yes. I will let you know when it changes.
Do
I just need to do it in my calculator?
This the right setup, man.
So you did it in your velocity final?
Uh-huh.
Yep. Perfect. Here's what page you
I'm sorry.
No, baby, I'm gonna tell you. You just use your calculator.
Okay.
So here we go.
1 second.
So I'm gonna let the woman with the calculator tell me what the numbers are.
Jay got the answer. Oh, you talking about me?
Yes, tell me what the answer. Tell me what the equation looks like. Tell me the numbers. Come on, baby.
A equals
Okay, so we got A equals 22 meters per second.
minus
44 meters per second
over 11.
over 11 seconds. And you're going to tell me, ma'am, what the answer is. Let's go.
-2. Oh.
She's going to tell me what her answer is.
Oh, I didn't know. I thought you were talking to me.
Thank you. Calculator, please, ma'am. Let's get your calculator out. Okay, let's see what's going to happen. So we're going to do alpha y equals. Alpha y equals. There you go. Y, and then over here. There you go. Now do you see how it gets that? Now do 22 minus 44. And now you're going to use that button over there on the right-hand side, and you're going to do 11.
This one.
Mm-hmm.
It was so old.
and then 11, and then hit enter. What you got? Huh? -2. Did everybody get a -2? So what's my unit?
Oh, that too.
All be squared.
Yeah.
Acceleration is always meters per second squared,
Why don't we second?
because I'm looking for acceleration. If I was looking for position, it would be meters. If I was looking for time, it would be in seconds. And if I'm looking for acceleration, it's meters per second squared. Do we feel good enough that we can go into the next section without doing the next problem? Everybody good? Okay, so turn to page 79. So 79 has 2 parts of motion. So the car is going and it brakes. It's going and it brakes, and it's going again. So it's not at a constant motion. It is the other equation, right? So if we look, it shows us how we're doing the reaction and how to do the answer. I want to give you a couple seconds to look that over. When you finish looking that over, turn to the next page, and we're going to do question number 28 on page 74.
74, 79.
I'm sorry, 74. We were on 73. I apologize. I need my glasses checked. I'm looking at this instead.
That's what you get.
Oh. Keep going.
Thank you, sir.
Okay. So do you think if I give you the equation, you can do the problem?
Yes, we can do the problem.
Okay, let's see if we can. All right, so I'm going to do question number
If all we have to do is hit alpha and y, right?
28. All right, boys and girls.
All right, girl.
Okay. This is different, right? Because it's a stop and a stop motion. Says change in position is what you're looking for, right? Velocity final squared minus velocity initial squared divided by 2 times acceleration. So let's look at the problem. Says a car with initial velocity of 24.5 meters per second east has an acceleration of 4.2 meters per second west. What is the displacement of the movement? And the velocity is 18.3 meters to the east. So I have velocity final, velocity initial, and acceleration. Mr. McAllister, what do you think velocity final is? Based on the reading assignment, babe. Ms. McAllister. So what do you think velocity final is? I don't know. What is my velocity final, baby? What did he end up at? Which one do you think? There's 2 choices. Just choose one of them, and it's meters per second.
Well, we ain't got the initial velocity.
Oh, excuse me. The velocity, excuse me.
What question is number on?
I'm on question number 28.
You hear me?
C28.
You already gave us the initial velocity.
What is our initial velocity?
24.5.
Oh. 24.5. All right, ma'am. So you can just tell me what the final velocity is. I'm sorry, baby. I did not hear you. I promise. What is it? Okay. All right. So Jeffrey, what is my acceleration?
4.2.
Okay, is everybody good so far? Can we plug it into our formula now? Based on we have this. Velocity final is 18.3 meters per second. We're gonna square that, right? Because that's what that says.
Thank you so
Let me
much.
slow down, you slow down a little bit.
Yes, ma'am, I'll stop. Okay, baby. So that's the first variable I have. And I'm going to subtract that by my velocity initial, which is this one. Okay? And it tells me to divide it by 2 times the acceleration. Okay. And what I need you to do, use your calculator and see if you can figure out what answer you get. It's very important for you to be able to use this now that we have it.
18.
Sleep is free. Amazing.
Going to the hill about 45 minutes. Okay, so you want me to put a square over 18.3?
So in your calculator, you're gonna do your alpha y equal, right? You're gonna put an open bracket, 18.3, close bracket with the square. You're gonna subtract, open bracket, 24.5, close bracket, and square that. Then you're gonna go over 2, open bracket 4.2, and close the bracket and hit enter.
2, open bracket, 4.2.
Correct, close bracket.
Negative 7.5. A negative.
Mm-hmm. Thank you, ma'am.
That's what you got?
I did.
That's what I got.
Whoa.
I got negative 7.5, 2, 1, 5, 4.
Yes, sir, and I just did a round part. I just stopped after the first digit after because this one only has 1 digit after, this one only has 1 digit after, and so does that one. So there's no reason for me to write it all down. I just have to write the 1 digit after. Is everybody good?
Thank you.
Yeah, I'm all right for just a second. What mode are you in?
Take this phone. Don't take this phone.
No, you're good.
No.
Who you taking?
You want to think, you want to think.
I need to.
Clear it again, baby, and see. And try to do it one more time, but if it doesn't, then I don't know, I forgot what to do. Okay. Remember, this thing is still rolling, and it can hear everything you're saying, just to make sure. Okay, so I feel confident we can go to 3. Y'all feel like y'all can go to section 3? I think we can. So let's go ahead. So go ahead and turn in your book to section 3, and it's going to talk about free fall. So free fall, the one thing you need to know is you need to know 9.8 meters per second squared. What is that? What is this number? What is 9.8 meters per second squared have to do with free fall? Look here. That's free fall. What does 9.8 have to do with that?
Right.
That is how much gravity is. When you throw something, gravity pulls it down And that number is your magic number for gravity. Put it in your notes, 9.8. So let's go ahead and let's turn to page number 78, please. Turn to 78.
It's 3.3?
This is 3.3. Yes, sir.
You made a calculator.
Yep. So we're going to do one problem, and that's it. We're going to be done. I'm going to give you a test out. You're going to see what you can do with it today. Okay? So I'm going to do number 41 on page 7.78. This is 3.3 on page 78. So what I'm going to do is I'm going to give you the formula. Okay? So maybe this is going to help. Number 41.
41.
I'll put it up here for you, baby. So velocity final equals velocity initial plus acceleration times time. Your acceleration during this time is going to be 9.8 meters per second squared. Okay? So now we'll have a constant acceleration unless it's stated. So for 41A, we are going to be using this. But what we're going to be doing is our velocity final is going to equal what? Because we got to find velocity initial, we got to find acceleration, and we got to find time. We're doing problem 41. Sure.
Oh, that's not bad. But do you know when we took the ACT or the AFCT test from last year?
If you took it,
Well, I know we took it. I asking like, do you know like
when it's going to come back, when we're going to get it. I'll tell you what, I'll call Miss Diana and I'll let you know and I'll send you an email. Is that okay? Because I know that's on your mind. So, for number 41, what is my velocity initial?
4.0.
0? Because
It is 0. What is my acceleration again?
9.8, negative 9.8.
Negative 9.8 meters per second. The only thing we got is time left.
It's fine for 4.0.
How long was it? 4.
4 seconds.
4 seconds. Okay? So we just got to plug this in, don't we?
Yes, ma'am.
So we're going to do 0.0 meters plus negative 9.8 meters per second,
Divided by
and we're going to times that by time. Okay? Now let me tell you. Here we go again, right? Remember that's a negative sign here. And we're wanting to do this first. Remember what we had to do last time? Okay. So we're going to have 2 brackets here. So it's going to be 0.0 plus open bracket twice. The negative button that you're going to use is on the bottom, right here where it says answer. That's your negative button. 9.8, close bracket, open bracket, 4.0, close bracket, and enter.
2 close bracket.
Yes, because you have to do this, because you're telling it to do this first, and then add it to that.
Negative 39.2.
Yep. Okay? Negative 39. Now let's look at B.
How far does it fall?
So it asks, how far does the brick fall during that, how far does the brick fall during that time? So what are we looking for this time? Position, right? X. Okay, so X equals velocity final plus half of the acceleration times time squared. There's your formula. Do we have everything now? It's okay. That's why I left it up for you. So this is B. on the same page. This is A. So if we look,
Our velocity final would be negative 39
yep,
plus half of
half of 9.8 times 4.0 squared. Exactly. So this right here was our velocity final. So our velocity final was negative 339 meters per second. So we're just going to plug that into here. Plus 1/2 time acceleration, negative 9.8, times time squared. Our time was 4.0 seconds squared. Now, we have to do that all together, don't we?
Yes, ma'am.
Okay. So it's going to be negative 39. So make sure you use the key that's down at the bottom, plus alpha y equal to get your fraction, right?
That's a bracket.
That is a bracket. Half, open bracket, negative 9.8, close bracket, open bracket, 4.0, 2 closed brackets afterwards. Yes, and make sure that's squared. Can I borrow your calculator, baby?
negative 39 plus.
I'm gonna do it on hers, and I'll come around if you're having a problem.
Negative. Open bracket.
I wish I was.
Close bracket.
And Simone, how you do the half thing?
Alpha y equal,
Close bracket. Close bracket. Square. Now put square after the close bracket and another close bracket.
you can put the square inside the closed bracket, please.
Negative 9.8.
Negative 117.4.
Yep.
Okay.
Here you go, babe. I'm gonna sit right, you see it? Okay, so let me show you how.
Negative 119.
So we have
Negative 119.
negative 39, okay, plus,
Negative.
and we're gonna do alpha y equals, excuse me, my fraction.
What you talking
1 over 2 over,
Which
so
is
open bracket. We're gonna use this for our negative, negative 9.8, close bracket, open bracket, and we've got 4.0, and I'm gonna use this button for square. Over, close, close.
What y'all should do?
Yeah.
What was your answer, Miss Long?
Same thing, you guys. You have to have one right here too. You have to insert a new one. Give me a second. And that's what I'm missing. Okay. I missed that one. But this is the thing, you've got to practice this, because this is gonna kill you. This thing right here is gonna kill you if you can't get the functions on there right, okay?
Miss Long, I need help.
Okay.
I got a 100. I got negative 19.
Okay, so let's see what you did. Okay, where's your half from? That would be half inside. That's why. Your half's inside, but you need to put the bracket on the outside. Mhm. You should be able to. Show us.
I did. It didn't show.
You hit enter. You hit enter.
Okay.
So, you have your square, you have your negative 9.8. Okay. So let's go over here and end up using the bracket.
All right, no, I'm over here.
So keep going over, let's make this up bracket. Keep going. Okay, see that bracket? You delete. Yep. Okay, now go over, go over a little bit more, and then you're gonna insert this time. One more time. And then hit your insert button.
I tried that.
So the insert is the blue one, so you need the blue and that. This one and that. Second, delete. Delete. Now put your bracket in.
Yeah.
Perfect. Now hit enter and see what happens. Go back up and hit begin what you got. Oh, you did 8.05. It's seconds. It's my wrong.
Oh,
That's an S. Okay, you got it.
So-
I'll show you this. This is the formula.
You show me how to do it, so I know how to do it.
I will. Okay, so now I'm gonna stop the video and I'm gonna give you your test.